Okay, so before you watch this video, you should have mastered how to factorize and solve simple quadratics, by which I mean quadratics where there's only one x squared, like x squared plus 3x plus 4, for example. This is the next step up, and to identify that, I call them complex quadratics, by which I mean there is a number of x squareds. And if we are asked to factorize a complex quadratic, because the question is harder, the solution method is more complex as well. Now I'll show you the first two examples together so you can see that I'm always doing the same thing. We start by taking the two numbers at either ends of the quadratic and multiplying. So 3 times plus 1 is plus 3, 10 times minus 3 is minus 30. Now from here it's very similar to a normal quadratic. I need two numbers that times to give 3 and add to give 4. So plus 3 and plus 1. Two numbers that times to give minus 30 and add to give 1, because it's 1x here. So plus 6 and minus 5. That's the first step done. What I do now, and this appears a bit mystical, is I take the number of x squareds and I put that on top of a fraction. And I take each of these two numbers in turn and I put that underneath the fraction, and then I cancel those fractions. So I take the 3 from there and the 3 from there and make it a fraction, and then I cancel that 1 over 1. I take the 3 from here and the plus 1 from here and make it a fraction, and that doesn't cancel. The same here, I take the 10 from here and the 6 from here, make it a fraction and cancel it. The 10 from here, the minus 5 from here, make it a fraction and cancel it. Now it turns out that these cancelled fractions tell me the numbers in my factorized brackets here. So the first bracket is 1x plus 1. The second bracket is 3x plus 1. And if you tried multiplying these brackets back out, you'd find that that was the quadratic that it took you back to. So the same thing here, the first bracket is 5x plus 3, and the second bracket is 2x minus 1. So if the question just asks you to factorize the quadratic, you can stop here because you've put it into brackets, you've factorized it. If the question asks you to solve, you need to do that little extra step, and here the problem is exactly the same as it was with the earlier quadratics. We've got one bracket times another bracket equals 0. The only way that's ever possible is if the first bracket is 0, in which case x plus 1 is 0, so x would be minus 1 by moving that to the other side, or the second bracket must be 0. So 3x plus 1 is 0, move the plus 1 across, divide by 3, x is minus 1/3. So these mean the same as they did previously. These are the only two numbers which, if I were to put them into this equation, would make it equal 0. And if I were to draw the graph of this parabola, it would cross the x-axis at minus 1 and minus 1/3. So the same thing here, I'd got down to two brackets multiplying each other to give 0. So the only way that's possible is if the first bracket is 0. So 5x plus 3 is 0, move the plus 3 across. 5x is minus 3, so x is minus 3/5. Or 2x minus 1 is 0, move the 1 across, x is a half. So there we have factorized and solved these two complex quadratics. Now pause the video for a moment whilst you have a go at the next two here. Okay. And the answers for the next two should have looked like that. Exactly the same method as higher up. You can freeze the video there and check your answers, and then try the worksheet.